Hi everyone, this is Aman Kumar. Welcomes all of you at Brilliant Academy. In today's lecture, we are going to learn our next chapter, that is polynomials. Okay, so let's start this lecture. Now, first we see what is polynomial. So, a polynomial is an algebraic expression in which variable have whole number as its power. So, if you have an algebraic expression and the variable of this algebraic expression have whole number in its power, then you say that this algebraic expression is a polynomial. Okay. Now look, suppose you have an algebraic expression 8x square plus 9y square plus 6z cube. Now, what is the variable of this algebraic expression? The variable is x, y, and z. These are the variable of this algebraic expression x, y, and z. And now look the power of the variable. Power of variable x is 2. Power of variable y is also 2. And power of variable z is 3. Now look, 2 is a whole number and 3 is also a whole number. Then what is the definition? An algebraic expression in which variable has whole number at its power. Then this algebraic expression is called polynomial. It's called polynomial. Understood? This algebraic expression is called polynomial. Let us take one more example. Suppose you have an algebraic expression like 6a cube plus 7b cube plus 5 c to the power 4. Now look in this algebraic expression. What is variable? Variable is a, b, and c. And look the power of variable. This is 3, this is 3, this is 4. Whole number, this 3 is also whole number, this 4 is also a whole number. Okay? Then this algebraic expression is a polynomial. Why polynomial? Because the variable of this algebraic expression have whole number in its power. Okay? So what is polynomial? An algebraic expression in which variable have whole number as its power. Then this algebraic expression is called polynomial. Okay? Now let's take more example. Suppose your algebraic expression look like 5x to the power minus 3 plus 9x to the power 9y x to the power minus 4. Okay. Now look, the variable of this algebraic expression is x and y, and power of x is minus 3 and power of y is minus 4. Now look, minus 3 and minus 4 is not a whole number. Is not a whole number. Why? Because whole number start from 0, 1, 2, 3. Okay. And this is minus 3 and this is minus 4. Then these are not a whole number. That's why this algebraic expression is not a polynomial. Not a polynomial. Why? Because variable does not have whole number as its power. Understood? Let's take one more example. Suppose your algebraic expression is look like 8 under root x plus 9 under root y. Now look, in this case variable is x and y. Now x is power 1 by 2 and in y has power also 1 by 2. Why 1 by 2? Why? Because you write under root as 1 upon 2. Now 1 upon 2 is not a whole number, again 1 upon 2 is not a whole number, then this algebraic expression is not a polynomial. Is not a polynomial. Why? Because in this algebraic expression variable does not have a power in whole number. Understood? What is polynomial? Polynomial is an algebraic expression in which variable have whole number as its power. Okay. Now next is degree of polynomial. Degree of polynomial means highest power of the variable. Degree means highest power of the variable. Suppose now look in this case. This is the polynomial and look the power of variable. X has power 2, y has 3 and y has 2 and z has 3. Now look definition. Degree means highest power. Degree means highest power. Now among these three, which one is highest? 2, 2, 3. 3 is the highest, therefore 3 is degree of this polynomial. 3 is the degree of this polynomial. If question occurs, write the degree of this polynomial, then you look for the highest power. And here highest power is 3, therefore degree is 3. Okay. Now in this case, look in this case 6a cube, 7b cube and 5c minus 4. Sorry, 4. Now look in this case, what is the highest power? Highest power is 4. Highest power is 4. Then degree of this polynomial is equals to 4. D is equals to 4. Degree is equals to 4. Okay. Understood? Let's take more example of degree of polynomial. Now you have polynomial 9x to the power 4 plus 5x to the power 3. Now look in this case, what is the degree? Look for highest power. This is 3, this is 4. Highest is 4. Therefore degree equals to 4. Understood what is degree? Degree means highest power of variable. Now let's move to our next topic, that is types of polynomial. Now polynomial is categorized in two bases. First one is on the basis of terms, and second one is on the basis of degree. Okay, now on the basis of term, polynomial is classified into three types. First one is monomial, when number of terms is 1. Second one is binomial, when number of terms is 2, and last one is trinomial, when numbers of terms is 3. Okay, now look, first is monomial, when number of terms is equals to 1. When number of terms is equals to 1, then this is monomial. Okay, so the example is 2x square. Now look, this is a one term, 9x to the power 1. This is also one term, 8 a to the power 4. This is also one term. Then this type of polynomial is called monomial. Now second one is binomial. Binomial when number of terms is equals to 2. When number of terms is equals to 2, then this polynomial is called binomial. Now look this example. If polynomial is like 5x to the power 2 plus 5x. Now look, this is first term 5x square and this is second term. Then there are two terms, first and second. Therefore, this polynomial is called binomial. Look one more example. Suppose 4 a to the power 5 plus 3 b to the power 6. Now look in this case. This is also binomial. Why? First term, second term. There are two terms. Therefore, this is a binomial. Now, last one is, that is third, trinomial. When number of terms is equals to 3. Number of terms is equals to 3. Then the polynomial is called trinomial. Look the example. Example is, suppose I write 2x to the power 9 plus 3y to the power 7 plus 9z to the power 8. Now look in this case. One term, two term, three term. There are total three number of terms is 3. There are total 3 number of terms. That's why this polynomial is called trinomial. Look one more example. Suppose you have 9x cube plus 8x plus 7. Now look, in this polynomial there are also three terms. First term 9x cube, second term is 8x, and last term is 7. So number of terms is 1, 2, 3. There are total 3 number of terms. That's why this polynomial is called trinomial. Understood? On the basis of terms, there are 3 polynomials. First is monomial, when number of terms is 1. Second one is binomial, when number of terms is 2. Third one is trinomial, when number of terms is 3. Okay, understand? Now look, second one, on the basis of degree. So on the basis of degree, total polynomials is divided into total 5 types. On the basis of degree, polynomials is divided into 5 types. First one is linear polynomial. When degree is equals to 1. When degree is equals to 1, then this is linear polynomial. Look example. Suppose polynomial is 9x plus 8y. Now look, what is the degree? Degree means highest power. X has power 1, y has power 1. Then highest power is 1. Therefore, degree is 1. That's why this is linear polynomial. Second one is quadratic polynomial. When degree is equals to 2. Then the polynomial is called quadratic. Look example. If a polynomial is like 9x square plus 8x. Now degree is highest power. Here x has power 1 and now here x has power 2. So degree is 2. Therefore this polynomial is called quadratic polynomial. Third one is cubic polynomial. In this cubic polynomial, degree is equals to 3. When degree is 3, then the polynomial is called cubic polynomial. Example, if a polynomial look like 7x cube plus 8x square plus 9. Now look, degree. Here power is 2, here power is 3. Highest power is 3, therefore degree is 3. And when degree is 3, then this polynomial is called cubic polynomial. Fourth one is constant polynomial. Constant polynomial. Constant means when degree is equal to 0. When degree is equal to 0, then the polynomial is called constant polynomial. Look the example. when degree is 0, which means variable has 0 in its power and 0 is a whole number. Now look, for constant polynomial, I like 7x 0. Now look this, anything to the power 0 is equals to 1, then this becomes 7, only 7, and this is constant. That's why it's called constant polynomial. When degree is 0, then the polynomial is called constant. And now last one is 0 polynomial. In case of 0 polynomial, degree is undefined. When degree is undefined, then we say this is a 0 polynomial. Now look example for 0 polynomial. If polynomial is like 0x to the power 9, now look, 0x to the power 9, result is 0. In this case, degree is not defined. Look another example. Suppose your polynomial is 0 y to the power 2. Now in this case, again result is 0. So this is a 0 polynomial. Understood? On the basis of degree, there are total 5 polynomials. First is linear when degree is 1. Second one is quadratic when degree is 2. Third one is cubic when degree is 3. Fourth one is constant when degree is 0. Fifth one is 0 polynomial when degree is undefined. Okay, understood? I hope you all understood this types of polynomial. On the basis of term, there are total 3: monomial, number of term 1; binomial, number of terms 2; trinomial, number of terms 3. On basis of degree, total 5: linear, degree 1; quadratic, degree 2; cubic, degree 3; constant, degree 0; 0 degree undefined. Okay. Now let's move towards our next topic, that is value of polynomial. Now look, what is value of polynomial? If px is a polynomial and x in x and alpha is a real number, then the value which is obtained by putting alpha in place of x is called value of polynomial. Suppose you have a polynomial in which the variable of polynomial is x, and now look, you have a real number, suppose 1, 2, 3, 4, anything, and you put this real number in place of x, then you get one value, then this value is called value of polynomial. Now look, we take one example. Suppose you have polynomial px is equals to 12x square minus 7x plus 1. Now this is a polynomial 12x square minus 7x plus 1. Okay, now read the definition. If px is a polynomial in x, this is a polynomial px in x, any value x, y, z, anything. Okay, and suppose you have given x is equals to 2. Okay, now look, alpha is a real number, this is alpha, 2 is a real number, and what is value? Then the value which is obtained by putting alpha in place of x. Now put this 2 in place of x, then we get one value, then this value is called value of polynomial. Now look, we put x is equals to 2 in place of x, then 12 in place of x we put 2, then this is 2 square minus 7, in place of x we put 2, now this is 1. Okay, now calculate this. This is 12 into 2 square is 4 minus 7 2s are 14 plus 1. Now look, this is 24. Now minus 14 plus 1 is minus 13. Okay, now subtract this, then we get 11. Then this 11 is the value of polynomial. Value of polynomial. Which polynomial? This polynomial 12x square minus 7x plus 1. Okay, look the definition. If polynomial px, this is a polynomial px and this is a real number. If I put this real number in place of variable x, then I get some value, then this value is called value of polynomial. Understood? Let's take one more example. Okay. Now suppose you have polynomial p y is equals to y square minus of 3y plus 9. Okay, now this is your polynomial. At y is equals to 3, find the value of this polynomial. At y is equals to 3, which means you have to put 3 in place of y. Now put 3 in place of y, then this is square minus 3 into, in place of y this is 3 plus 9. Now calculate this. 3 3s are 9 minus 3 3s are 9 plus 9. This will cancel, then what is the value? 9. This is the value of polynomial. Which polynomial? This. Okay, this is the value of this polynomial. Understood? Now let's move towards our next topic, that is zeros of polynomial. Zeros of polynomial means the value of variable at which our given polynomial becomes 0. Then we say this value of variable is called 0 or roots of the polynomial. 0 or roots of the polynomial. The value of variable at which the given polynomial becomes 0, which means px is equal to 0. Then this value of variable is called 0 or root of the polynomial. Let's understand by taking one example. Suppose we have a polynomial 3x minus 3, okay, and this is given that x is equal to 1. We have polynomial 3x minus 3 and the value of variable is given 1. Okay, now after putting x is equal to 1 in place of x in this given polynomial, if this polynomial becomes 0, then we say that yes, x is equal to 1 is a 0 of polynomial. Okay, now let's check. Put 1 in place of x, then 3 into, in place of x we put 1 minus 3. Now calculate this. 3 1 ja 3 minus 3. Now this becomes 0. When we put 1 in place of x, then our polynomial becomes 0. Then we say yes, therefore 1 is the root or zeros of the polynomial. Which polynomial? Polynomial px is equal to 3x minus 3. Then 1 is the root of polynomial 3x minus 3. Understood? If the polynomial becomes 0 after putting the value of variable, then this value of variable is called zeros of polynomial. Understood? Now let's take one more example. Suppose we have polynomial px is equal to 9x square plus 9, and we have given x is equal to minus 3. Okay, x is equal to minus 3. Then what is zeros? If after putting this minus 3 in place of x, this polynomial becomes 0, then we say yes, minus 3 is a 0 polynomial. If this polynomial becomes does not 0, then we say minus 3 is not a 0 polynomial. Let us check. P is equal to minus p, in place of x we put minus 3. Now add 9 into minus 3 square plus 9 is equal to 9 minus 3 square is 9 plus 9. Now look, 9 9 ja 81 plus 9. This will become 90. This is not equal to 0. If I put minus 3 in place of x, the polynomial become 90. This is not equal to 0. So therefore minus 3 is not a 0 of polynomial. Understood? What is 0 polynomial? 0 polynomial means the value of variable at which our given polynomial becomes 0. Then we say yes, this value of variable is the 0 of polynomial. If our polynomial does not become 0, then we say this value of variable is not a zeros of polynomial. Okay, understood? What is zeros of polynomial? Now let us see a polynomial have how many zeros. Now look, we have one polynomial 9x plus 3, second is 5x square plus 3x plus 9, and we have last polynomial 9x cube plus 8x square plus x plus 2. Now we have to find how many zeros does this polynomial have. So for this finding how many zeros, there is a concept. What is concept? Maximum number of zeros is equal to degree of polynomial. Degree of polynomial. Okay, maximum number of zeros is equal to degree of polynomial. Okay, if a polynomial have degree 1, then maximum number of zeros is 1. Okay, if polynomial have degree 2, then maximum number of zeros is 2. Okay, if degree 1, then maximum number of zero is 1. If degree is 2, then maximum number of 0 is 2. If degree is 3, then maximum number of 0 is 3. Understood? Maximum number of 0 is 3. Now look this polynomial. In this polynomial, what is degree? Degree is 1. Then maximum 0 is equal to 1. Now look at this polynomial. Degree is 2. Highest power 2, then degree is 2. Then maximum 0 is equal to 2. This polynomial also have 1 0, 1 or 2, maximum 2. Okay, this polynomial does not have 3 0. Why? Because maximum number of 0 is 2. This polynomial have 1 0, either 1 0 or 2 0. Okay, now look in this case, degree is 3, then this polynomial is have maximum zeros is equal to 3, which means this polynomial have 1 0, 2 0 or 3 0. Okay, not more than 3 0. Understood? How many zeros of a polynomial have? Maximum number of 0 is equal to degree of polynomial. Okay, when degree is 1, maximum number of 0 is 1. When degree is 2, maximum number of 0 is 2. When degree is 4, maximum number of 0 is 4. When degree is 99, maximum number of 0 is 99. Okay, now move towards our next topic, that is finding 0 of a polynomial. First we see how to find a 0 of a linear polynomial. Okay, then we see quadratic polynomial. Now look, this is a linear polynomial 9x plus 3 because degree is 1. Now for first polynomial px is equal to 9x plus 3. Now for finding zeros, first we do is polynomial px equal to 0. First we do we put polynomial px is equal to 0. Then now polynomial px 9x plus 3, 9x plus 3 is equal to 0. Now this is a linear equation. Now from here 9x is equal to minus 3, then x is equal to minus 3 upon 9, then this is, then what is zeros of this polynomial? Minus 1 upon 3. 0 of this polynomial is minus 1 upon 3, or root of this polynomial is minus 1 upon 3. Let's check it. Minus 1 upon 3 is root or not. For checking this is root or not, we put x is equal to minus 1 by 3 in place of x in this polynomial, and after putting this value, if this polynomial becomes 0, then we say yes, this is the root of this polynomial. Now let's check. For checking, put x is equal to minus 1 upon 3 in our polynomial px, that is 9x plus 3. Now p in place of x we put minus 1 upon 3 is equal to 9 into minus 1 upon 3 plus 3. Okay, now 3 3 is 9, 3 into minus 1 is minus 3 plus 3. Now look, after putting x is equal to minus 3 in place of x in this polynomial, we get 0. We get 0, which means this polynomial becomes 0 after putting minus 1 upon 3. Therefore, yes, x upon minus 1 upon 3 is a 0 of this polynomial. Our answer is right. Understood? Now let's check our second example. Let's solve our second example. Second example is 5x plus 10. Second polynomial is px equals to 5x plus 10. Now polynomial px equals to 0. Then px is 5x plus 10 is equal to 0. Now from here 5x is equal to minus 10. This 10 goes that side, and this is minus 10 is equals to x is equal to minus 10 upon 5. Then 5 to the 10. So x is equal to minus 2. Now minus 2 is the 0 of this polynomial. Now we check this is true or not. Now for checking, we put x is equal to minus 2 in this polynomial 5x minus 10 in polynomial px, that is 5x minus 10. Sorry, 5x plus 10. Now in place of x we put minus 2. So 5 into, in place of x minus 2 plus 10. Then 5 into 2 is minus 10 plus 10. Now look, this polynomial becomes 0 after putting x is equal to minus 2. Therefore, yes, this is a 0 polynomial, which is x is equal to minus 2, which means yes, minus 2 is the 0 of the polynomial. Okay, understood? Now let's solve our next problem, that is 2x minus 50. Now third one is polynomial px is equal to 2x minus 50. Polynomial px is equal to 2x minus 50. Now first step, do px is equal to 0. Now polynomial px is 2x minus 50 is equal to 0. Then 2x is equal to this minus 50 goes that side and become plus 50. Now x is equal to 50 upon 2. This cancels 50 by 25 times. Then x is equal to 25. Now this is the 0. 25 is the 0 of this polynomial. Let's check it. For checking, put x is equal to 25. X is equal to 25 in polynomial px, which is 2x minus 50. 2x minus 50. Now put 25 in place of x. Then 2 into, in place of x, 25 minus 50. Now look, 25 to the 50 minus 50. This will become 0. After putting 25 in place of x, our polynomial becomes 0. So yes, 25 is the 0 of this polynomial. Understood? Now we see how to find the zeros of quadratic polynomial. Now for finding zeros of a quadratic polynomial, x square minus 3x minus 10, we perform a factorization by splitting the middle term. We do factorization by splitting the middle term. Okay. Now for splitting the middle term, first step is multiply these two. For splitting middle term, first step we multiply these two, 10 and x square. Third term constant and coefficient of x square. We multiply third term constant 10 and coefficient of first term, that is x square. Now look, if you multiply these two, 10 and x square, if there is nothing, then 1. Then when we multiply 10 and 1, 10 into 1x square, then what is the answer? 10x square. Okay, now in second step we split 10 in two terms. We split 10 in two terms. Suppose we split 10 into terms a and b. Like that, if you add a plus b, then we get result minus 3. If we add a and b, then we get minus 3, and if we subtract a and b, then again we get minus 3. Okay, split this result 10 in two terms like that. If we add or subtract these two terms a and b, we get minus 3, and if we multiply a and b, we get 10x square. Okay, split 10 in like that. If we add or subtract these two terms, we get minus 3. Why? Because this is minus 3. We get middle term minus 3, and if we multiply these two terms, we get 10x square. Understood? Now, for splitting this, we do prime factorization. We do prime factorization of this result. Now, 2, 5, and 1. We get 5 or 2. We get 5 or 2. We write 10 is equals to 2 into 5. Okay, now look, these are my two terms 5 and 10. Okay, we have 5 and we have 2. Now if we add these two, 5 or 2, we get 7. Then we can't perform addition. Now subtract this 5 minus 2, then what we get? 3. 5 minus 2, we get 3, but we have to get minus 3. If we subtract 5 minus 2, we get 3, but we require minus 3. That's why we can't perform this. So what we perform? We like 5 plus 2, minus 5 plus 2, then we get minus 3. Then we do this one, minus 2 plus 2, sorry, minus 5 plus 2 is equal to minus 3. Okay, now we get this one. Now after multiplying, we have to get 10x square. This one is minus 10. This is minus 10. Okay, and this is plus x square. Now after multiplying these two, we have required minus 10 x square. Now for this first term minus 5, second term 2. Now multiply this, we get minus 10. We get minus 5 multiplied by 2, we get minus 10. Now this is our two terms. First term is minus 5, second term is minus 2. Now right here, x square minus, first I write plus 2x minus 5x minus 10. Okay, now we take common from these two, then these two. Okay, first we take common from these two, then from these two we have x as common. Then what we left? Here we left x, plus here we left only 2. Now from these two we take common minus 5. Then if minus 5 is common, then we have left x, and in this case we left 2. And I use plus and y because minus we take common, therefore this will become plus, this will become plus. If we take minus sign as a common, then our sign becomes change. If we take plus sign as a common, then our sign remains same, does not change. Okay, now look, this is common, x plus 2, x plus 2 is common. So I write x plus 2. Then what we left? Here we left x, and here we left minus 5. Now after factorization we get x plus 2 and x minus 5. Now for zeros, what we do? For zeros, first step we do polynomial px is equal to 0. Okay, then if we do polynomial px equal to 0, then this will look like that. Now again first we check x plus 2 is equal to 0, and in other x minus 5 is equal to 0. Now from here x is minus 2, and now from here x is 5. And in starting what I say, maximum number of zeros is equal to degree of polynomial. Degree of this polynomial is 2, then maximum number of zeros is 2, and first 0 is minus 2, second 0 is 5. Now let's check this one is 0 or not. If minus 2 and 5 is the zeros of this polynomial, then after putting minus 2 and 5 in this polynomial, our polynomial becomes 0. Okay, so now let's check it. This is 0 or not. Now check it. First we check for minus 2. Okay, first we check for minus 2, then put x is equal to minus 2 in polynomial px. Okay, now what is px? Px is this one, x square minus 3x minus 10. X square minus 3x minus 10. Now in place of x we put first minus 2. So minus 2 square minus 3 into minus 2 minus 10. Now calculate. Minus 2 square is 4. Minus minus plus 3 to the 6 minus 10. Now 4 plus 6, 10 minus 10 is equal to 0. Yes. When we put p equals to minus 2, then this polynomial becomes 0. Therefore x minus 2 is a 0. Now check for 5. Now check for 5. So for 5, put x equals to 5 in our given polynomial px. Now what is the polynomial px? Px is x square minus 3x minus 10. Now put 5 in case of x. Now in x we put 5, then 5 square minus 3 into 5 minus 10. Okay, now 5 5 is 25, 3 5 is 15 minus 10. Now minus 15 minus 10 becomes minus 25, then minus 25 is 0. Now after putting p is equal to 5, then again our polynomial becomes 0. So this is right. Minus 2 and 5 is the zeros of this polynomial x square minus 3x minus 10. Okay, you all understood how to find zeros of quadratic polynomial by using factorization, which factorization by splitting the middle term. Okay, now look, these are the basics of polynomials. That why I can't explain in details, I only explain in brief. Why? Because you all had already studied polynomials in your class 9. That's why I can't explain in details. If you want a detailed explanation of all these concepts, then you go back and check out my class 9th lecture of polynomials. In that lecture you get all the concepts in details. Now let's move toward our next topic, that is geometrical meaning of zeros of the polynomial. This is the first topic of our class 10th. But before understanding this, first we look what is graph of polynomial. Now look, graph of polynomial of a linear polynomial. Linear polynomial means where degree is 1. The polynomial whose degree is 1 is called linear polynomial. Okay, now look, the graph of linear polynomial is a straight line graph. Graph of a linear polynomial is a straight line graph. Okay, now for quadratic polynomial, graph of a quadratic polynomial is a parabola. Graph is parabola. Parabola is a shape, this shape, a shape like that. We say this is parabola. Okay, parabola. Now look, this is also a graph of quadratic polynomial, and this is also a graph of quadratic polynomial. Okay, now in this case the opening of this parabola is in upward, and in this case the opening is in downward. Okay, now look, a first you understand what this is, the general form ax square plus bx plus c. This is the general form of quadratic polynomial ax square plus bx plus c. Now in this case a is the coefficient of x square. When this coefficient a is greater than 0, which means when a is positive, then this graph is look like that. The mouth of parabola is in upward direction, and when this a is negative, which means minus 1 minus 2 minus 3, then the mouth is in downward direction. Okay, understood? When a is positive, then the mouth of parabola is in upward direction, and when a is negative, then the mouth of parabola is in downward direction. Understood? For linear polynomial, graph is straight line, and for quadratic polynomial, graph is a parabola. Okay, now when a is positive, then parabola is in upward direction, and when a is negative, then the mouth of parabola is in downward direction. Okay, understood? Now see what is geometrical meaning of zeros of polynomial. Now look, geometrically the zeros of polynomial px are the x coordinate of the point where the graph of px intersect the x-axis, which means suppose you have a quadratic polynomial or linear polynomial, then the graph of these polynomial intersect x-axis, then the coordinate of this x-axis is called geometrical meaning of zeros of polynomial. Now look, suppose this is your graph, this is a straight line graph. I draw a graph of a linear polynomial. Now look, this one is y-axis, this one is y dash, this is x-axis, this one is x dash. Now look, this is a straight line, which means this is the graph of linear polynomial. And now look, this graph intersect x-axis at this point. X is this point. Now then the coordinate x coordinate, then x coordinate of this point is called the zeros of polynomial. Suppose this x coordinate of this point is minus 2, then minus 2 is the zeros of this linear polynomial. Understand? Now look, in case of quadratic polynomial, graph is like parabola. Suppose this is the graph of quadratic polynomial. Look, in this case, what is a zero? Zeros means x coordinate where the graph touches the x axis. Okay, so in this point, this graph touch, and at this point, this graph touch the x axis. Now, then coordinates this and this. Then x coordinates of this point and x coordinate of this point is called the zeros of polynomial. Suppose this is minus 4 and this is this is 6. Suppose this is minus 4 and this is 6, then minus 4 and 6 are the zeros of quadratic polynomial. Understand? And in this case, mouth is opening in upward direction, which means a is greater than 0. If I draw this graph like that, then in this case a is less than 0, which means a is negative, and the zeros is x coordinate of this point and x coordinate of this point. Understood? Geometrical meaning of zeros of polynomial. Let's understand by taking some example. Okay, now look, this is a question. Question is what? the graph of y is equals to px are given. These all are the graph of polynomial px, and we have to find the number of zeros. We have to find number of zeros, not we have to find zeros. We have to find number of zeros. So what I say, what is geometrical meaning of zeros of polynomial? Which means geometrically meaning of zeros means these are the x coordinate of x axis on at which the graph of polynomial intersect the x axis. Now look for this graph. What is zeros? This is the zeros. Zeros is what? X coordinate where the graph touches the x axis. Now for this polynomial, this graph touches x axis at this point, at this point. Okay. And now look for this graph touch x axis at first this point, second at this point, third at this point. Okay. And now look for that. This is the graph, and this line does not touch this x axis. Okay. Now for this, number of zeros is 0. Okay. Now for this, how many times this point touches x axis? One time. Now so in this case, number of zeros is 1. Now look for this, how many times? One time, two times. Then number of zeros equals to 2. Okay. Now look for this, one time, two times, three times. Then for this polynomial, number of zeros is 3. So what is the result? Number of zeros is equals to number of times the graph touches the x axis. Okay. Number of zeros equals to number of times the graph touches the x axis. Suppose you have a graph like that. Now how many zeros does this polynomial have? One time, two times, three times, four times, five times, six times, seven times, eight times. Then number of zeros equals to 8. Why? Number of zeros equals to number of times the graph touches. This graph touches x axis at 8 times. Therefore, number of zeros is 8. Understood? Now our next topic is relation between zero and coefficient of a quadratic polynomial. Okay. Now first we see what is the general form of quadratic polynomial. Okay. First, general form. Now the general form is ax square plus bx plus c. Okay. Now where a cannot equal to 0. Why? If a becomes 0, then this will look like bx plus c. And now this bx plus c is not a quadratic polynomial. This is a linear polynomial. Why? Because degree is 1. In this case, degree is 2. That's why this polynomial is quadratic polynomial. Okay, understood? General form ax square plus bx plus c. Okay, now how many zeros does have this polynomial? Number of zeros is equal to what? Number of zeros. We discuss maximum number of zeros is equal to degree of polynomial. Maximum number of zeros is equal to degree of polynomial. Now quadratic polynomial have degree 2, then number of zeros is 2. Okay. Now let's name this zero is alpha and beta. Now let name these 0 be alpha and beta. Okay. We name this 0 be first alpha and beta. Okay. Now what is the relation? So relation is what? Sum of zeros is equals to minus b upon a. Minus b upon a. B is what? Coefficient of x, this variable, and a is coefficient of x square. Okay. Sum of zeros minus b upon a, that is sum of 0 alpha plus beta is equals to minus b by a, that is coefficient of x. I write here coefficient of x. Coefficient of x minus coefficient of x, not coefficient of x, minus coefficient of x upon coefficient of x square. Okay. Now sum of zeros means alpha and beta. Alpha plus beta is equals to coefficient of x square. Coefficient of x is b. Okay. Upon coefficient of x square is a. Okay. And there is minus. Then alpha plus beta is equals to minus b upon a, minus b by a. That is sum of zeros is equals to minus b by a. Now one another relation is product of zeros. Product of zeros. This is equals to coefficient of, this is equals to constant upon coefficient of x square. Now product of zero is means alpha multiplied with beta. Alpha into beta is equals to constant term. Constant term is c. Constant term is c upon coefficient of x square is a. So a. So product of zero is equals to c upon a. Sum of zero is equals to minus b upon a. Understood? First we see what is general form of quadratic equation. So quadratic polynomial. This is ax square plus bx plus c, where a is cannot be zero. Now number of zeros is equal to degree of polynomial. When degree is 2, then number of zeros is equal to 2. Now we name the zeros alpha and beta. Okay. Then sum of zeros, that is alpha plus beta, is equal to minus b upon a. Minus b is coefficient of x. A is coefficient of x square. Okay. Now product of zero is alpha into beta. Alpha into beta is c upon a. C is constant term and a is coefficient of x square. Okay, understand this? Now let's see this question. Question is what? Find the zero of a quadratic polynomial and verify the relationship between zeros and coefficient. We have this polynomial. Okay, first we have to find the zero of this polynomial, then verify the relationship. Okay, so now first finding zero. For finding zero, we do factorization by splitting the middle term. Okay, so first step we multiply these two, 8 and x. Then this is equal to 8x square. Okay, then second step we split 8x square in two terms like that. If we add or subtract these two terms, we get minus 2, and if we multiply, we split in two terms like that. If we add or subtract these two, then we get minus 2. Okay, and if we multiply, then we get 8x square. Okay, now 8 split 8, 4 to the 8, 4 to the 8, 4 into 2 is equal to 8, and 4 minus 2 is 2. Okay, now we have to get minus 2, then minus 4 plus 2 is minus 2. Okay, then we have two terms, 4 and 2. Now x square minus 4x plus 2x minus 8. Then from these two we take x as common, then what we left, x minus 4. Now from these two we take plus 2 as common, then what we left, x minus 4. Now x minus 4 is common, then x plus 2 we have left. Okay, now for zeros what we do, first we do polynomial px is equal to 0. Okay, then if we do this is equal to 0, then this equal to 0, this equal to 0, and this equal to 0. Now then x minus 4 is equal to 0 and x plus 2 is equal to 0. Okay, now from here x is plus 4, this minus 4 goes that side and becomes plus 4. Now from here x is equal to minus 2, then our 0 is 4 and minus 2. Okay, these are the two zeros of this polynomial, minus 4 and minus 2. Now we have to verify the relationship between zeros and coefficient. So we have alpha is equals to minus 4 and beta is minus 2. Now what is the relationship? Alpha plus beta, sum of zeros, is equals to, we have two relationships, alpha plus beta is equals to minus b upon a, and second one is alpha beta is equals to c upon a. Okay, now we have to verify these two relationships. So first we verify this one. Okay, alpha plus beta is equal to minus b upon a. Now for this we first do in LHS. LHS is this one, alpha plus beta, alpha plus beta. Okay, now alpha is 4, beta is minus 2 plus minus 2, then this will become 4 minus 2 is 2. Okay, now RHS. RHS is minus b by a, minus b upon a. Okay, now minus b upon a. B is, look this, b is coefficient of x, that is minus 2. Minus b upon a, that is minus, and this one is minus 2. Here we have minus 2 and a. A is 1, coefficient of x square is 1. 1. Now look, this minus becomes plus, then RHS is also minus, RHS is 2. LHS is 2, therefore LHS is equal to RHS, which means verified. That means this relation is true. Now for alpha and beta, that is product of zeros, for alpha beta this is equal to c upon a. Okay, now alpha beta, alpha is 4. First we in LHS alpha beta, alpha is 4, beta is minus 2, then this is 4 to the 8, minus 8. Now RHS c upon a, c upon a. Now c is minus 8, minus 8. Now in place of c I get minus 8, and a is what, coefficient of x square, that is 1. So here RHS is equals to 8 minus 8. Now look, LHS is minus 8, RHS is also minus 8. Therefore, LHS is equals to RHS, which is verified, which means this relation is true for a quadratic equation. Understood? What I do first, question is asking for find zeros of polynomial and verify the relationship between zeros and coefficient. First I do find zeros by factorization by splitting the middle term. Then we get two zeros, 4 and minus 2. Now we have to verify this relation. First, alpha plus beta is equal to minus b upon a. That is sum of zeros is equal to minus b upon a. LHS is sum of zeros, alpha plus beta. Then I put 4 plus minus 2, then I get 2. Now RHS minus b upon a. Then I put coefficient of b, it is minus 2. Minus 2 upon coefficient of a, that is 1. Now this minus change the sign of minus 2, this becomes 2. Now LHS is equal to RHS, therefore verified. Now in case of alpha beta, product of 0 is equal to c upon a. LHS is alpha and beta. Now 4 into minus 2, alpha is 4 and beta is minus 2, then I get minus 8. Now RHS c upon a. C is constant term, that is minus 8. A is coefficient of x square, that is 1. Now c upon a minus 8, therefore LHS is equal to RHS, that's why this one is also verified. Okay, got it? Now let's move towards another question. This question is just same like first one. In this question again we have to find 0 of this polynomial, and after finding zeros we have to verify the relation. Okay, so our polynomial is root 3x square plus 10x plus 7 root 3. For finding 0, first we do this polynomial is equal to 0, then px is equal to 0. Okay, now polynomial px is root 3 x square plus 10x plus 7 root 3 is equal to 0. Okay, now next step, multiply these two. Multiply these two, constant term and coefficient of x square. So multiply root 3 into 7 root 3. What we get? 7 into 3. Root 3 becomes 3. Then 7 3 is 21. Okay, now we have to break 21 in two terms like that. If we add or subtract these two terms, we get 10x, and after multiplying these two, we get 21. So we break 21 in two terms. First term is 7 and 3. 7 3 is 21. 7 plus 3 is 10. Okay, now our term is 7 and 3. Look, root 3 x square plus 3x plus 7x plus 7 root 3 is equal to 0. Now third step, we have to take common from these two and these two. First we take common from these two. From here what is common? X is common and root 3 is common. X and root 3. Root 3 and x. Why root 3? We write root 3 into 3. That is equal to 3. That's why I take root 3 as common. Now root 3 is common. Then from this term, what we left? Only x. Now from here we left plus root 3. Okay. And now let's take common from these two. From these two we have common only 7. Then I take 7. What we left? X plus. From here I left root 3 equal to 0. Okay. Now again we take common root x plus root 3. X plus root 3 is common. Then x plus root 3. What we left? Root 3x plus 7. Root 3x plus 7 we left is equal to 0. Okay. Now x plus root 3 is 0. X plus root 3 is 0. Then x is equal to minus root 3. And under root 3x plus 7 is equal to 0. Then from here x is equal to minus 7 upon under root 3. Okay. Now we have zeros. First one is minus root 3, second one is minus 7 upon root 3. Okay. Now next what we do, we have to verify the relation between zeros and coefficient. Okay, so let's verify this. For verification, first is what? Alpha plus beta is equals to minus b upon a, and second one is alpha beta, that is c upon a. Now we have to verify this relation. Okay, first we verify this one, sum of zeros, then alpha plus beta is minus b upon a. LHS is alpha plus beta. Okay, now alpha is minus root 3. Okay, now beta is minus 7 root 3. Minus 7 root 3. Okay, then root 3 is LCM. Okay, now root 3 is LCM. There is nothing than 1. Then 1 root 3. Then root 3 into root 3 is 3 minus. Okay. Now look, this is minus 7. So I write here minus 7. Then what is the result? Minus 7 minus 3 is minus 10 upon root 3. This is our LHS. Now let's go to RHS. RHS. What is RHS? minus b upon a, minus b upon a. Okay, minus b. B is 10. B means coefficient of x, that is 10, and here minus sign, then minus 10, and a is coefficient of x square. X square is root 3, then root 3. Now look, LHS is minus 10 upon root 3. RHS is also minus 10 upon root 3. Therefore, LHS is equal to RHS, which means relation is verified. Now let's do for this one, product of zeros. Product of zeros, that is alpha beta is equal to c upon a. Now first LHS, that is alpha beta. Alpha is minus root 3, and beta is minus 7 upon root 3, minus 7 upon root 3. Now look, root 3 cancel. Then this is minus, minus plus. Then LHS is 7. Now for RHS, c upon a. C is constant term, constant 7 root 3. 7 root 3. A is coefficient of x square, that is root 3. Then root 3. Okay. Now root 3 cancel. Then RHS is 7. LHS is 7. RHS is 7, which means LHS is equal to RHS. LHS is equal to RHS. Therefore, relation is verified. Understood? What is the question? Question is, this is a polynomial. We have to find the zero of this polynomial, and after finding zero, we have to verify the relation. Then first, using factorization, I find zero. Zero is minus root 3 and minus 7 upon root 3. Okay. Then after finding zero, I verify the relation. First relation is sum of root is equal to minus b upon a. Now sum of root is equal to minus b upon a. LHS alpha plus beta. I put the value of alpha and beta. Then after calculating, I get minus 10 upon root 3. Then after RHS, minus b upon a. Minus b means coefficient of x. A means coefficient of x square. Now put coefficient 10. Coefficient of x square root 3. This minus. Then this is minus 10 upon root 3. LHS is equal to RHS. Therefore, this is verified. Now, in case of this one, second relation, that is product of root is equal to c upon a. C is constant term. A is coefficient of x square. Now, LHS, alpha beta. Alpha is minus root 3. Beta is minus 7 upon root 3. Root 3 cancel. I get LHS 7. In RHS, c upon a. C means constant term. Constant means 7 root 3. Constant is 7 root 3. And a means coefficient of x square. Coefficient of x square is root 3. Root 3 cancel. Only 7 left. Then LHS is 7, RHS is also 7. LHS is equal to RHS, therefore relation is verified. Okay, got it? Now see our next question, that is, if alpha and beta are zeros of quadratic polynomial this x square minus 5x plus 4, then what we have to find? We have to find the value of alpha plus beta and alpha, 1 upon alpha and 1 upon beta. Okay, what is the question? Question is that if alpha and beta are the zeros of a polynomial, that is x square minus x plus 4, okay, and we have to find the value of 1 upon alpha and 1 upon beta. Okay, now if this type of questions come, then you just forward the second line, find the value of this one. Okay, if you see alpha and beta are the zero of polynomial, okay, if you see alpha and beta are the zero of polynomial, then forward the second line of question, just forward second line and find sum of roots and product of roots. Okay, whatever the question is saying, we don't matter. First we see alpha beta polynomial, alpha beta zeros, and we see polynomial. Then first step you have to find alpha plus beta, and second alpha plus alpha beta. Okay, first you have to find these two, sum of roots, product of roots. Okay, after finding these two, we read the question and do the question. Okay, so first step, I find alpha plus beta and alpha beta. Understood? Now for alpha plus beta is equals to minus b upon a. Alpha plus beta is minus b upon a. Now minus b upon a. Polynomial is this one, minus b upon a. B means coefficient of x. Coefficient of x is minus 5. Minus 5. Okay. Now a. A is coefficient of x square. Coefficient of x square is 1. Now okay. Now minus b. This is alpha plus beta is equals to 5 upon 1. Okay. Now second product of root alpha beta is equals to c upon a. C means constant term. Constant term is 4. 4, and a means coefficient of x square. Coefficient of x square is 1. So this is equal to 4 and this is equal to 5. Now we have alpha beta and alpha beta. Okay, now I read the next question. Okay, whenever I see alpha beta as a zero polynomial, then first I find alpha beta and alpha beta. Okay, now I read the next question. Question is what? Find the value of 1 upon alpha and 1 upon beta. Okay, question is asking for value of these. Question is asking for 1 upon alpha plus 1 upon beta is equal to what? Now just take LCM of these two. Okay, now solve these. Then LCM is alpha beta. Okay, now there is alpha, denominator is alpha, then this is beta plus this is alpha. This is beta, this is beta, beta and alpha. Okay, now alpha plus beta is equals to alpha plus beta 5. Alpha beta is equals to alpha beta 4. Then our answer is 4. Okay, our answer is 4. Question is what? If alpha and beta are the zeros of polynomial x square minus 5x plus 4, then we have to find 1 upon alpha and 1 upon beta, 1 upon alpha plus 1 upon beta. So first I forgot this line. I only read this one. Alpha beta is 0 polynomial. Okay, alpha beta is 0 of polynomial. Then what we do? In first step, I find sum of roots, product of roots. Okay, then after finding this, I read the next part of question. What is the question? Find the value of 1 upon alpha and 1 upon beta. Okay, so I write here 1 upon alpha plus 1 upon beta. Then I calculate this. Then we take LCM alpha beta, then beta plus alpha in at numerator. Now alpha plus beta is 5. I put here 5. Alpha beta is 4. I put here 4. Then my required answer is 5 upon 4. Okay, but now let's move toward next question. Question is what? If alpha beta are the zeros of quadratic polynomial x square minus x minus 4, then we have to find the value of 1 upon alpha plus 1 upon beta minus alpha beta. Again the same question. Again same mistake. First I forgot this line. Find the value of this. First I did this. Alpha beta are the zero of quadratic polynomial. This. Okay. I see alpha beta polynomial. I see alpha beta and polynomial. Then first step I find alpha plus beta, alpha beta. Okay. Then first step I find sum of roots, that is alpha plus beta, and second product of roots, that is alpha into beta. Okay. Now sum of roots is equal to minus b upon a. Okay. Minus b upon a. Minus b means coefficient of x. Coefficient of x is minus 1. Minus 1 upon a is 1. Then this is 1 upon a 1, that is equal to 1. Now alpha plus beta, alpha beta, c upon a. C means constant term, that is minus 4. Minus 4 and a 1. This is equal to minus 4. Okay. This is equal to 1. I write here 1. Now what we have to find? This one. 1 upon alpha, 1 upon beta minus alpha beta. Now for this we have to find 1 upon alpha minus 1 upon beta minus alpha beta. Okay. Now first I calculate only these two. Only these two. Why? Because I get the value direct, alpha beta. That's why I calculate only these two. Now calculate this. Then LCM is alpha beta. Now here beta plus alpha, and this is minus alpha beta. Okay. Now alpha plus beta is 1. Alpha plus beta is 1. Alpha beta is minus 4. I write here minus 4. Now minus alpha beta is minus 4. Okay. Then this is minus 4. Now this one become minus 1 upon 4. And this is plus 4. Now I take LCM. LCM is 4. Then minus 1 and 4. This is nothing, the 1. So 4 4 is 16. Now this will look like 15 upon 4. Understood? This is final answer. 15 plus 4. Let us see it again. Question is what? If alpha and beta are the zeros of quadratic polynomial x square minus x minus 4, and we have to find the value of 1 upon alpha plus 1 upon beta and minus alpha beta. Okay. So this is the same question. Now first step, just forget this one. Okay. Now just forget, read this one. Alpha beta polynomial. We have alpha beta polynomial. Then first step, we have to find sum of root and product of roots. First step, we have to find these two. Sum of root, product of root. Then sum of root is 1. Product of root is minus 4. Okay. Now let's see the question again. What is the value? 1 upon alpha, 1 upon beta minus alpha beta. Okay. I write it this. Now calculate. After calculating, I get 15 upon 4. Okay. Understood? Now look our next question. Question is what? If one of the 0 of a quadratic polynomial 4x square minus 8kx minus 9 is negative of others, then find the value of k. Now look, there is a polynomial 4x square minus 8kx minus 9. Okay. And question is given that the 0 of this polynomial is negative of the other. 1 0 of this polynomial is negative of the other. Okay. Which means suppose first 0 is alpha, then second 0 is negative of other, which means negative of alpha, then second 0 is minus alpha. Understood? If first 0 is alpha, then second 0 is minus alpha, because look, one of the zeros of this polynomial is negative of the others. Then first is alpha, then second is minus alpha. Okay. Now next step is what? Whenever you see alpha beta and polynomial, then what we do? We do first find sum of roots and product of roots. Then we do our next step. Now for this, first let the first 0 be alpha, then second 0 is minus alpha. Now first we have to find sum of zeros. Sum of zeros is equal to minus b upon a. Okay, now sum of zeros means alpha plus minus alpha. Second is minus alpha. First is alpha, then alpha plus minus alpha, and minus b upon a. Minus b means coefficient of x. Now look, coefficient of x is 8k, minus 8k, minus 8k. Now this is minus, and a means coefficient of x square. X square is 4. Now 4. Okay. Now this alpha minus alpha is equal to, this is minus sign, change the sign of 8, that is 8k plus 4, 8k by 4. Okay, now this becomes 0 is equal to 8k upon 4. From here 8k is equal to 0 into 4. Now from here k is equal to 0. Why 0? This is 0 upon 8, therefore k is equal to 0. This is the answer. K is equal to 0. Okay, let's understand this again. Question is what? Question is, if a polynomial, there is a polynomial that is 4x square minus 8kx minus 9, and question is said that the 0 of this polynomial, 0 of this polynomial is negative of other 0, then we have to find the value of k. Okay, so first I let first 0 is alpha, then according to question second 0 is minus alpha because second is negative of others. Now first I find sum of zeros. Okay, and sum of zeros, that is alpha plus second 0 minus alpha is equal to minus b upon a. Minus b is coefficient of x, a is coefficient of x square. Now alpha plus minus alpha, coefficient of b is minus 8k, I write minus 8k, and coefficient of a is 4, I write 4. Now this minus, this minus. Okay, alpha minus alpha is 0, this minus, change the sign, that's why this becomes plus 8k upon 4. Now from this, after this I calculate, then I get k is equal to 0. Okay, now let's move towards our next topic, that is formation of a quadratic equation. Okay, for this formation we need two things. First is sum of roots, and second one is product of roots. Okay, so we need two things, that is sum of root, which is alpha plus beta, and product of roots, that is alpha beta. Now if we have these two, sum of roots and product of roots, then we form a quadratic polynomial, that is quadratic polynomial is equal to k x square minus alpha plus beta x plus alpha beta. Okay, this is our quadratic polynomial. When we have sum of root and product of root, then our quadratic polynomial is k x square minus sum of roots, that is alpha plus beta x plus product of root, that is alpha and beta, and here k is any real number. Okay, k is any real number. Understood? Here k is any real number. Now let's do some example. Now look, we have a question. Question is what? A quadratic polynomial 2x square minus 3x plus 1 has zeros alpha and beta. There is a quadratic polynomial, this, and the zeros of this quadratic polynomial is alpha and beta. Okay, so then we have to find a quadratic polynomial whose zeros are 3 alpha and 3 beta. Okay, there is a polynomial this, and the zeros of this polynomial is alpha and beta. Then we have to find a polynomial whose zero is 3 alpha and 3 beta. Understood? Now what I said, that whenever a polynomial and 0 is given, you have to first find sum of zeros and product of zeros, that is alpha plus beta and alpha beta. Okay, first you have to find these two. Then after finding these two, read the next part of question. So first we find alpha plus beta for this polynomial. Okay, so first I write which polynomial, px is equal to 2x square minus 3x plus 1. Now for this polynomial, alpha plus beta is what? Minus b upon a, minus b is minus 3, a is 2. So here b upon a is 3 upon 2. Now alpha beta is c upon a. C means constant term 1, a is 2. So alpha beta is 1 upon 2. Now read the second part of question. What is the second part? Now form a quadratic polynomial whose zeros are this alpha, 3 alpha and 3 beta. Okay, so for quadratic polynomial we must have sum of zeros, now sum of roots, and product of root, POR, SOR and POR, sum of roots and product of roots. For forming a quadratic polynomial, we must have these two. Okay. Now we have to form a polynomial. Suppose we have to form GX polynomial. Okay, and the root of this GX is 3 alpha and 3 beta. Now from these 3 alpha and 3 beta, we find sum of root and product of root. Okay. Then after finding these two, we put in formula. Formula is what? K x square minus alpha plus beta x plus alpha beta. Understood? First, we have to find sum of root, product of root by using these roots of our quadratic polynomials. Okay. Then after finding these two, we put in this formula and we get our required quadratic polynomial, that is gx. Okay. Now let's do it. Now for polynomial gx. Okay. Now SOR, that is sum of root alpha plus beta, is equals to alpha is first root is 3 alpha and second 3 beta, then 3 alpha plus 3 beta. Okay. Then 3 common alpha plus beta, and look, this is our equation first and we take this is equation 2. Now alpha plus beta is 3 upon 2. We find alpha plus beta, that is 3 upon 2. So I put 3 into alpha plus beta is 3 upon 2. 3 upon 2 from first. Okay. Now this is 9 upon 2. Okay. Now alpha beta, that is product of root. This is alpha beta, which means 3 alpha multiplied with 3 beta. Okay. Now so 9 alpha beta and alpha beta is 1 upon 2. So this is 9 into 1 upon 2, which is 9 upon 2. Now we have SOR and POR for polynomial gx. Now how we find? We put SOR and POR in the formula. What is the formula? Then polynomial gx is equals to k x square minus alpha plus beta, that is sum of roots x plus alpha beta. Now for this gx polynomial, SOR alpha plus beta is 9 upon 2. So I put, now in place of k, we don't put right here. Now this is k x square minus alpha plus beta 9 upon 2, 9 upon 2x plus alpha beta 9 upon, alpha beta is also 9 upon 2, 9 upon 2. Okay. Now look, for here I take LCM. We take LCM as 2. Then this will become 2x square minus 9x plus 9. Okay. Now put k is equal to 2. Now put k equals to 2. Why 2? Because we have to cancel these two. Then when we put k equals to 2, then gx is equals to 2x square minus 9x plus 9 upon 2. These two is cancelled. Therefore our required polynomial gx is equals to 2x square minus 9x plus 9. This is our required polynomial. Okay. Understood this? What is the question? Question is what? There is a quadratic polynomial 2x square minus 3x plus 1, and the zeros of this polynomial is alpha and beta. Then we have to find the polynomial whose 0 is 3 alpha and 3 beta. First step, I forward the second part of question. I see polynomial iska 0, polynomial and zeros. Then I find alpha beta and alpha beta for this polynomial. Then I get 3 by 2, 1 by 2. Now for polynomial gx, that we have to require, that we have to find a polynomial. So find SOR, sum of root for this polynomial. Roots are given. Then from roots we find SOR 9 upon 2. From roots POR, it is product of root 9 upon 2 again. Now put these two in formula. Alpha plus beta x plus alpha beta 9 upon 2x plus 9 upon 2. After calculating this, I get the polynomial 2x square minus 9x plus 9. Okay. Now our chapter polynomial is over. If you found this video helpful, then like, share and subscribe to the channel. Okay.